Before the video starts, wanted to let everybody know that I do have the large, extra large hats back in stock. I was out for a while and a lot of people were asking, okay? So if you're interested in the large, extra large hats, check out HVACRvideos.com, my website. We got shirts, hats, all that stuff. As far as the hats go, I've talked about them before, but I purposely had these hats designed without my logo, okay? They just say HVACR, and that way I was hoping that it wouldn't interfere with people's uniforms, right? Because it's not promoting my brand, it's just promoting HVACR, which the acronym is pretty broad, right? So the other thing about the hats too is they're a breathable material and they have a black underbill. I put a lot of thought into the design of these hats because when we work, you know, the underbill on the hats, they always got really dirty and I never liked that. So black underbill, so it still gets dirty, but it's not as noticeable. And then the hats are made with like a breathable material. So they are a flex fit, but they're not, I don't know. It's hard to explain. They're not a traditional style. Like you're not gonna be able to see this, but I can see light through the top of the hat because it's totally breathable. So check them out at HVACRvideos.com and let's go ahead and get on with the video now. This video is brought to you by Sporlan. Quality, integrity, and tradition.
All right, we've got a complaint of an office / kitchen AC not working. That's this guy right here. So we're going to go ahead and open it up and see what we can figure out. All right, we've got our control box here. You can see it's really dusty because we're out in the Coachella Valley, very sandy out here. We're gonna start by checking incoming power. I don't need to open up the disconnect switch if I can simply check right here. So 1 to 2, 208. This is a 3-phase system. 1 to 3, 210. 2 to 3, 209. And just to make sure, yeah. So we have 3-phase power coming into this guy. Just out of curiosity, we're checking the transformer to see if it's tapped right, and it is because we've got 208 volts. So we're going to need to go ahead and come on over here to our thermostat wiring and see if we can figure something out here. So let's go from R to C, 24 volts. So the control transformer is working, and then we're going to go from C to Y1. And it looks like 13 volts or something funky there. And then let's go C to Y2, 7 volts. C to W, nothing. All right, so there's something funky there. And looks like maybe we're gonna need to figure out what's going on with the thermostat possibly. Yeah, this looks like a smoke detector right here. And it looks like it's breaking what? That's weird. It's only breaking one wire. What's going on here? This might be disconnected. I don't know what's going on there. Yeah, that is kind of, oh no, smoke detector. Yeah, that's weird. I'll have to figure that out. All right, well, let's look at the thermostat. This one has an interesting thermostat, and I'll show you guys. So our filters are really dirty. This unit has an energy management system, and the energy management system hasn't worked for a long time on this AC. And then we had installed a temporary thermostat many years ago, and the customer hasn't approved the quote to fix the energy management system. So at this point in time right now, the thermostat is actually not calling. So we're gonna go ahead and turn it on. Set it way down. And see, it says cool on now, so thing's junk, huh? Sometimes you got to do what you got to do to get them running, especially when EMS systems are in the mix, because it's getting approvals and it's a mess. So we should be calling, so let's go back over to the electrical panel. It's weird, we're still getting a crappy connection, 13 volts. That's weird. If I go from C to G, because the indoor fan's running, we get 26 volts. Okay. From C to Y1, we get 13 volts. All right, I tell you what, let's throw a jumper wire on there and see how that changes things. All right, we're gonna clip a jumper wire from R to Y1. Oop, looks like we came off. Sometimes jumper wires can be fun. R to Y1. Obviously the unit did not start up. Let's test R to Y1. So what kind of voltage reading we're getting. Now that we've done that. Oh duh, R to Y1, we're not gonna get anything. Let's go. There we go. So now we're getting a 24 volt voltage reading, which makes me think maybe we've got multiple things going on here. Like the thermostat's not allowing proper power to go through, but I don't know if that's the only problem. You know what I'm saying? Because the jumper wires are kind of being a pain. But when I put the jumper wires on there, we get 24 volts from Y1 to C. C is being our common terminal. So let me put that back on there better, and then we'll continue on. All right, I got a much better connection, and still Y1 to C gives me 26 volts now. So with the jumper, I get better voltage at the terminal board, but the unit's still not turning on. Let's take a look at this schematic here real quick. So they are seriously trying way too hard with this schematic. I'm not going to be able to explain it to you, but on the schematic, it's not a super easy one to read. But essentially what's happening, power from the transformer is coming into the board. The board is getting a thermostat reading and deciding what to do. You've got a bunch of different options on this guy. You can have an economizer, all that crap. In our situation, we don't. So when we go through Y1, it's going to go through your low pressure switch, then your high pressure switch. So if we go across our low pressure switch, we get 26 volts, meaning that the low pressure switch is open. That low pressure switch is our problem. Now, are we out of gas, or do we have a bad low pressure switch? For that, we're gonna need to put service gauges on this guy to figure it out. Our compressor's in here, and we have trying to see if I can depress this with my finger. Oh yeah, I don't think there's any gas in there. I think we're out of gas. Looking for anything obvious. There's all kinds of wire rub outs. Nothing there. All sorts of stuff that are almost potentially going to rub out. That right there. I don't see anything down there. Okay. Well, let's get some gauges on it. So I went ahead and pulled the top off the unit. I still haven't put service gauges on it, but I think, just from investigating, the leak is going to be, there's oil around the dryer and around that suction line drip loop right there, or discharge line. So I think we're going to have a cracked line somewhere, maybe on that dryer or something like that. Hard to say, but we're going to get some gas in this guy. All right, this guy's completely flat. Like I said, we're going to open up some nitrogen. This guy on test. And purge. Put a little gas in here, see what happens. Looks like my nitrogen might be a little bit low. Or we just have a really big leak. No, doesn't seem like it's pissing out. Alright, let's keep going. We'll keep putting some gas in there. I was hearing hissing sound, but I think it just might be the gas passing through my hoses. I think I might be running out of nitrogen here. Oh yeah, we're definitely low. That's cool. We'll get what we can out of it. Get 100 PSI or so in there. Alright, or some Viper Big Blue on there. Right down in here. It's got a cracked liquid line. It's just spraying out. So we need to change that dryer and get it up and running. So I'm trying to make my life easier here. So super simple. I just unsweat the discharge line going into the header and the liquid line coming out of the condenser. I got another person here. We're going to lift this condenser over here, make the repair, clean the condenser, put it back in. Got the condenser pulled out and went ahead and unsweat very carefully that little piece right there, and I'm currently redoing it. So I just made the bottom piece right here, approximately. It's kind of close. And then we're going to make the top piece and try to mimic it, and then I'll do whatever I have to do to make sure that dryer gets screwed into that condenser. So this way maybe we don't have another cracked line. I believe it was cracked right up in here. Kind of cool. If I can take this, we can pressure test it and play with it later. But yeah, getting there. And the condenser itself is not even that bad. I thought, you know, the inside of it, I'm looking at it. It's just this other side needs a rinse, but we'll do that. All right, we got this guy put in. It's all one piece now. A little ugly right here, but it's all good. It worked out. I ended up having some solder drip down here, so I ended up heating up this joint too. You got to be careful when you're doing these right here. It ended up splitting on me. It happens. The copper's really thin on these condensers where they swage it. So that's why there's so much solder, because I had to fill up the crack. But yeah, it's good. I think we can lift this guy in now. So I'm holding it because I'm waiting for the solder to bond before I let it go. So I'm waiting for the ultimate color change, and then I'll let it go like that. So now, there's no real easy way to do this. I got to get this bottom one in here, which is going to be tricky to push up. See how it popped out. Okay. Now, this guy's under a weird bind, so it's going to want to pop on me. Like that, dang it. That's awkward. So that kind of sucks because it keeps popping off. So I'm going to have to figure something out here. This dang thing wants to be a pain. Gosh darn it, it keeps popping off. Alright, I'm going to have to do something to get pressure underneath that dryer so that way it doesn't pop off anymore. Yeah, this is really awkward in here. Let's see if I got this. Heat up around the back side. I don't know if you can see, but I had to prop my drill and the dryer box down there. Kind of silly. Kind of an awkward location. I think that took. I still gotta find a way to secure the dryer too. All right, we're gonna inspect that guy with the mirror now, make sure that the braze joint was good. Kind of popped a few times, but I think we're okay. That's not too bad. I kind of had to finagle my way out of there, but yeah, it's actually going to work fine. I'll be able to take some plumbing strap, wrap it around, and screw it to the condenser right there. So, and the dryer turned out really nice right there. What I'm going to do now, we decided not to wash it outside because it's only dirty in that one spot. So we're going to go down, get the vacuum pump running, and then we'll start working on securing the dryer and rinsing the condenser. But I want to get that vacuum pump running on this guy. So that way that part is done. We still got to secure these guys in here, so we still got a little moving around to do. All right, we passed our pressure test. We've gone up 0.8 psi in pressure because it started off when we got here, it started in like the high 70s, low 80s, and it's pushing 90s right now. So as the temperature rises, the pressure increases, and this further proves that nitrogen does change pressure, okay? And it is changing pressure in this system right now. So I'm confident we don't have any refrigerant leaks, okay? And we've been running for about 22 minutes too, by the way. So I'm confident we don't have any pressure leaks. We're gonna go ahead and let the nitrogen out. Now, because this guy has the Cormax high flow Schraders right here, we cannot take the Schraders out. So we're gonna use a Schrader depressor, okay? This is gonna depress the Schrader so that way we can get good flow through it. But I'm gonna tell you right now, these things are not 100% leak free. So keep that in mind as we're doing our evacuation. I guarantee you we're not going to pass the decay test because these things are probably going to leak. But I'm confident we don't have any refrigerant leaks or, you know, system leaks. It's just going to be either moisture and or these guys right here that are leaking. So I've still got a little pressure in here, but we've got these core depressors on here now. And trust me from experience, you do not need to torque these things down really hard. Just mid-seat them, and that's plenty, okay? You'll end up ruining the high flow Schraders. So just finger loose, just like that. Don't got to go torquing on them. So once that's done bleeding out the remaining nitrogen, we're going to hook up the vacuum hoses and let this guy get going. So we've got the gas ballast open, so we're trying not to contaminate the oil for the initial pull down. We're at about 3,200, 33,000 microns. So once, I typically like to see it get to about 2,000 to 1,500 microns, and then I close the gas ballast. Now, if you notice something, I'm actually pulling only on one side. I ended up not using this hose. I hooked it up just in case I needed it, but I don't think I'm gonna need it. So we're getting a true evacuation reading because this is valved off and this is in the system right now. So we're about 2,000 microns. So here in just a second, I'll go ahead and close the gas ballast. So the evacuation's doing good. We're at about 600 something microns. I'm just vacuuming the evaporator out. We're gonna clean this guy, and then I'm also gonna pull the blower assembly. So working on it right now. I really like this cordless Milwaukee vacuum for this kind of stuff. This blower assembly is caked with grease all in the veins, all inside. So we're gonna go super heavy duty with the cleaner. We got the Viper brightener, which is really gonna get that grease off of there, but it's super strong, so you gotta be careful. And I got the foam sprayer here too. Now, someone had recently asked me, is it bad to get the cleaner in the bearings? And I would imagine so, yes. But what can you do? I mean, I'm gonna do my best to try to keep it out of the bearings, but you can only do so much when you have a greasy blower assembly. You know, I can change all the components instead of degreasing it, or we can degrease it, and then if we lose a bearing, you know, change all the components then. So I don't know. But in this case, I'm gonna do my best to keep the cleaner out of the bearing, but you know, you can only do so much. Every time I use this new foam sprayer, I'm blown away. Look at this crap. That is badass. Nice and good in there. Gets all inside that thing. That stuff is awesome. You guys can get this from TruTech Tools. If you guys use the offer code Big Picture, get a discount on it. I get a small commission. You help me out. So this thing is awesome though. It's from Refrigeration Technologies. You're not really supposed to do this, but I'm having to use that brightener cleaner on the evaporator too because it's so greased up. That's not just lint, that's all grease. So you know, you just got to rinse it off real quick, and you got to be careful about the fumes. This thing's nasty. Stuff coming out of it is pretty crazy. Just downright greasy and nasty. But it's coming clean. Stuff's doing a good job. All this stuff was the stuff stuck in the little veins. It's definitely coming clean. It's still got some goobers in it, but I mean, it's a million times better than it was, and it's actually going to move air now. So we're going to give it another good rinse, and then I'm still working on this evaporator right now, just giving it rinses. Got the bottom half kind of clean, still got a little bit of crap on the bottom. Still got to work on the top too. Well, it's much better than it was. It's not absolutely perfect, but it's never going to be. There's grease in the ducts and stuff, so I'm gonna go ahead and slap the filters back in, put some sanitizer on it, and we're gonna continue with putting this unit back together. My evacuation's doing really good. 540, that's pretty awesome, 547. So again, I'm telling you, those core depressors are leaking, so I'm not gonna be too worried about it. Gonna take the Strike Back sanitizer, just kind of cover everything, and again, you don't rinse this stuff. Spray it all over the coil, blower wheel, inside panels. Just some peace of mind. I got a copper strap on that dryer down there, just some plumber's tape, and we're looking for 14.2 pounds. We're at 3 pounds right now. I'm charging in through the high side. I dig how the scale, I think it's the SRS3 scale, I think, communicates with the S-Man 480 manifold. There we go, we're done. Close this guy off. It already took it. All right, so we're gonna start this guy up and hope that there's nothing else wrong with it. So this guy's still jumped out, so it should start right up. Everything should be good. There we go. And we're gonna let it run, see how it operates, give it a little bit to stabilize out. This is what we're looking at. Measure Quick's actually giving me the green flag, like all is good. Numbers are all looking good. I'm not seeing any issues here. Temperature split looks good. Airflow looks decent. Guys, I'm happy with this, extremely happy. So, you know, this unit is, you know, not in the greatest of shape, but it's not horrible. I think it has plenty of life left. The condenser fan motor certainly looks a little rough, but it's still operating. The condenser's in decent shape. We didn't need to chemically clean it because all was well. I still need to kind of look at this thermostat issue. Well, let's see. If I pull this off. Yeah, thermostat's working. So I don't know why I was getting that weird low voltage reading or something earlier, but it's giving me a good reading. It's pulling in. I looked at the contactors earlier. I didn't see any problems with those. I did go ahead and rinse in here, so we've got a nice clean condenser all the way around. So I noticed this thing wasn't coming on. All of a sudden the thermostat doesn't have a display anymore, but the indoor blower motor's running. So this now it just shut off. This thermostat's out of whack. I got it all dirty, but it's not gonna make a difference. I threw in a thermostat in here, set it up. It's reading 99 degrees right now, but have it all set up and programmed. So we're gonna drop it down into the duct. Now, of course, I will say this, that I want them to fix their automation system, but they don't. So this is what I have to do to make this equipment work until they approve the automation system replacement. Essentially, they have an antiquated, or not an antiquated, but they have a system that they don't want to use anymore. It's a Siemens system, and in order to change over, they have like 9 ACs or something like that. It's just a huge project, and they just haven't wanted to attack that. So we've got like 3 ACs that have these thermostats dropped into the duct temporarily. So, I can only do what I can do.
All right, they're not always the most difficult calls. Sometimes they're just time consuming, but you still have to go through everything, okay? It's starting to get warm. This call was actually out in the Coachella Valley. It's a little ways away from my shop, but it was about 95 degrees throughout the day. So, you know, it was warm on the roof, but I have to say it was super nice, and I'm liking the warmer weather. Now, where my shop is at, it's not quite 95 degrees. It's in the 80s. But it's still warming up, and the service calls are starting to come in. So I'm super stoked for that because we have been so slow for the longest time. So it'd be nice if we get a nice little pick-me-up and a couple heat waves coming through. That way we can generate some service calls for sure. I'm sure you guys are probably dealing with some of the similar stuff or hoping for the service calls and stuff. So anyways, but we started with the basics, okay? You know, I saw the weird electrical issue with the control wiring, and, you know, then I diagnosed the low pressure control issue, worked my way to the refrigerant leak, but still followed up in the end, you know, cleaning everything up. It's also important to know the limitations of your tools. Now, I talked about those high flow Schrader core depressors leaking. Unfortunately, that's just what they do, so they're not 100% leak free. Now, if you use a normal vacuum core removal tool, they're much better at, you know, being used in a vacuum, essentially. They work a lot better, okay? But those high flow depressors, I don't know, just my opinion, they just, I've bought several of them, and in the beginning they're great, but eventually they start leaking. So it's just one of those things that I need to go ahead and replace mine probably and get a new set. But you have to understand the limitations of your tools. So in this situation, I knew I wasn't going to pass a perfect decay test, but I knew that the leak wasn't really going to be, you know, in my system, right? Because I did a pressure test with nitrogen and everything was good. So once I hit the evacuation, I went ahead and just pulled those things off as quick as I could, and then ended up putting normal service gauges on there, evacuating the service gauges, and then charging the system up after that. Now, I didn't get putting the normal service gauges on video, but you guys get the point. So we went ahead and started the system up, of course, and let me preface everything with saying that I had the customer in the loop the entire time. They were aware of everything, okay? So from the initial find, even though I don't say it on the video all the time, I'm holding the customer's hand the entire way saying, hey, this is what I'm finding. but I'm very cautious to say, you know, it's low on gas or it's out of gas, but I don't know if that's the only problem. Okay, so that way when I ran into the thermostat issue, it's not a big deal. Since I had the unit apart to do the leak repair, I took it upon myself to go ahead and clean the unit up too. Now, I get a lot of questions and feedback on why the units are greasy. Just dealing with kitchens. Kitchen ACs are always greasy. This one's like an office slash kitchen AC, but it still just sucks up the grease. And, you know, yeah, I know that's not right. Yeah, I know that, you know, this and that and this and that, but inevitably this is what we have to deal with occasionally when we deal with restaurants. Okay, so you just got to learn to roll with the punches and degrease the units as best as possible. I can't control all the ductwork. All I can do is make the customer aware that they've got grease buildup in their ductwork, and you know, it's kind of on them. Of course, I always note it on the invoices and everything kind of to cover my butt, but also using the coil cleaner. Now I use the Refrigeration Technologies Viper Bright coil cleaner. Okay, you got to be so careful, and you got to understand how these cleaners work. Okay, that cleaner is a highly corrosive. It etches the coil, but it strips anything off the coil along with the first couple layers of metal, essentially. Okay, so you know, you can only do so much when you have something that's this greasy. Sometimes you got to do what you got to do. Okay, but you need to understand, using that cleaner, it does have some fumes, so you don't want to spray it if there's air moving across the evaporator to where it would potentially get down to the occupied space or the customers. You know, you don't want to clear a building out because of coil cleaner fumes or something. Okay, so you want to be aware of your surroundings, make sure the customer understands everything that's going on. You know, in this situation, I didn't have to worry about it, but sometimes I could be brazing in the airstream, right? I could be fixing a leak on the evaporator, and then because the building's negative or something, I'll go warn the customer, hey, there's going to be smoke coming down through the ductwork. It's me. Don't freak out. You know, that kind of stuff. So always be aware of your surroundings. Keep the customer in the loop. Okay. I really, really appreciate you guys making it to the end of the video. If you haven't already, please check out my website, hvacrvideos.com. I said in the beginning, the hats are available. Those just got back in stock. We have plenty of stock of everything else. So if you're interested, help to support the channel, check it out, okay? hvacrvideos.com. Remember, I do live streams Monday evening, 5 p.m. Pacific on YouTube. Work permitting, of course, and then also go live on the HVAC Overtime channel Friday evenings, usually around 6:05 p.m. Pacific time with the Overtime guys, and we usually just kind of recap the week and talk about everything. So definitely come check it out. Yeah, I think that's pretty much it. I really, really appreciate you guys, and we will catch you on the next one, okay?